Okay, this is what we did today in class. Well, some classes had this for homework on Monday night, and it is now Tuesday. So we went over this. I checked to make sure that we finished it, and then we went over it today in class. And some classes did this together. So what this is a graphic organizer showing your states of matter and different aspects or different characteristics about that matter. So I'll focus that in. The very first thing I ask you to do here is to draw your visual representations. So these look a lot like those particles that were in your reading. And so you notice here this is kind of a cube shape. You don't have to draw it exactly the way that I drew it. The thing is that the particles are fixed position, they're close together. And I also drew this kind of inside of a glass to show you that if I placed an ice cube, that would be a solid, right? If I placed it in a glass, it's not going to change shape. It is going to be still a cube even while you put it in a different container. The liquid particles are a little bit more relaxed. They fill up the bottom. They spread out to fill up the bottom of the container. Gas particles have all these arrows showing that they are going every which way, and if this container didn't have a lid on it, not to say that it even does, but the gas would escape from that container. Plasma is very similar because you have your particles, but also notice you've got the little bitty particles. It acts very, very much like a gas because it's a charged gas. So these little bitty particles right here are actually your electrons, your free electrons that are floating around or moving around very, very quickly, because this is a plasma, which is really just a charged gas. So when we look at the shape of each one and the particle arrangement like we just drew, this is kind of what we drew in words. The shape is fixed for a solid, and the arrangement of the particles is very close. A liquid can change shapes, so if I pour this liquid from this container maybe into a container that has a different shape, maybe it's smaller and wider or taller and thinner, or has a wavy shape, this liquid will take the shape of that container. Like a Coke bottle has that design, curved design, and it would take the shape. So it does change shape, and it has that relaxed arrangement. Still, those particles are close, but not as close together as they are in a solid. And then on a gas, the gas changes shape as well, so it will take the shape of any container I put it in. So that's why when you inflate a bicycle tire or a tire to your car or a kickball or a basketball or a football with air, that gas takes the shape of that container that it's in. So it will change shape. The particles in a gas compared to the particles of the solid and liquid are very, very far apart. And for a plasma, again, changes shape because it acts just like a gas. Particles are far apart, and they also have free electrons. For the volume is, think about it, the amount of space that it takes up, or the amount of space that it would occupy. The solids is fixed. It's not going to change. The liquid, because of that attraction between those particles, is fixed. It's not going to grow to take up more space or spread out to take up more space because it just doesn't have that much energy. The gas is going to change the volume. It's going to spread out and fill up the space. So if I'm in an enclosed tight area and I light a firecracker, one of those stink bombs, and let that smoke, that gas kind of fill. If I put it in a box and close it up, it'll fill that box, right? If I light it and put it in the corner of the classroom, that smoke will eventually, permeate or dissipate or go all the way through the classroom. So you can kind of think of that. It's going to spread out to fill the container that it's in. So that's here, and so will a plasma, because again, a plasma acts very similar to a gas. Particle movement, remember the vibrations with our hands. We did this number in class. I don't know if you remember my hands. Solid particles are close together and vibrate back and forth. Liquid particles break free and go around and around. Gas particles move farther apart, so they're going a lot faster. And plasma particles, remember, they're going so fast, just like the gas, but the electrons are free. So that's why if I have my fingers moving, showing that you have free electrons. So not only do you have your atoms moving, but you got all kinds of craziness going on there. So you've got a lot of movement extremely fast. movement there. The energy level, if we had to go from lowest to highest, of course our solid's the lowest because of that slight vibration, to the highest with the most extreme movement in a plasma. So these kind of are somewhere in between. If we had to rank these as energy level, this would have the lowest energy level. So if we were ranking them lowest to highest, that would be number 1 with the lowest, number 4. This would be a 2 and a 3. So if I had to rank them from lowest to highest, the more the energy for the liquid is more than a solid, but it's less than the gas and the plasma. A gas has a high energy, but not as high as plasma. So if you're only comparing these three, which a lot of times they are only comparing solid, liquid, gas. And plasma is not necessarily an option sometimes. We're just getting to the point where techs and stuff are placing plasmas in there kind of, common rather than just the 3 states of matter. The density here, remember density is how much space, how much stuff is in the amount of space. So if I took, remember I've got the medicine ball in class and the kickball, they're both about the same size. That medicine ball is much more dense because there's more stuff inside. It's filled with sand. And then the kickball has just air inside, so there's not as much stuff, so it's less dense. So when we're comparing solids, liquids, gases, and plasmas, we're not talking about like, a solid piece of wood compared to water, compared to oxygen. We are talking about if I had that one thing. So let's just think about water. If I just think about water, or I just think about gold, or I just think about neon, generally your solid has the highest density. It will, if you think about putting them in a container, the solid should sink. And I said generally here because there are exceptions. It's not an absolute. If you think about ice and water, of course ice is going to float. So, but generally, like if I had gold and I had a bar of gold or a chunk of gold, and then I also had liquid gold, the density, the gold chunk is going to sink to the bottom of the liquid gold there. So generally the solid has the highest density. There's more stuff. The particles are closer together. Generally the liquid has a lower density than a solid, so it would float on top of the solids, but higher than a gas, so it would sink underneath the gas. So think about it, if I had a jar again of gold, and I had gold in all of these states of matter, I would have my chunk of gold down here at the bottom. This would be the chunk of gold, and then I'd have my liquid gold right there. That would be filling up the next part, and then up here I'd have my gas, right? I'd have my gas, my gold gas, if I could do that. And if I could even ionize it and get it to be a plasma, the plasma we would find up here at the top, at the very, very top. And so that's just in theory. That doesn't really happen. But again, we're comparing gold to gold and whatever. But there are some exceptions to those. Again, like the ice and the way that it crystallizes, and actually when water freezes it expands, so that makes it take up a little bit more space than when it was a liquid because of its and we'll get to it, but the way the molecules are shaped, when they crystallize, when they freeze and become a solid, their form actually locks them into where they expand and take up a little bit more space. So that's kind of an exception to that rule. So anyway, this is going over this. So this should be in your notes. Again, I just checked it for completion. It was not a grade. So if you were here on Monday and you showed up on Tuesday and you were also here, you should have had this done, and we went over it in class. So that's that.